Alright, so I'm going to real quickly go through the factors that affect solubility. So, there are really three things that can affect the solubility of a substance. And you actually already know most of these things. So this is the factors affecting solubility of solutes in solvents. Alright, so we have structure effects, pressure effects, that's probably the new thing, and temperature effects. So let's talk about structure effects first. So you already know this. Things that are both polar, they'll dissolve. Things that are both nonpolar, they'll dissolve. Polar substances won't dissolve in nonpolar substances and vice versa. In biology, they use these words, hydrophobic and hydrophilic. Hydrophobic just means water-fearing. Hydrophilic means water-loving. So water-loving are our polar substances. Water-fearing are our non-polar substances. So the like the cell membrane of the membrane of cells, where you have like the bilipid layer, that's where you have like the hydrophobic end and the hydrophilic end, and they combine and they make that semi-permeable layer. Hopefully you guys have already learned that. I don't know when they teach that. But yeah. So cool. Structure effects, polarity, and all that stuff affects how things will dissolve and whether or not it will be soluble. Pressure effects. Pressure only affects gases. Right? So there's little effect on solid or liquids just because those molecules are already close together. So this is really only going to affect the solubility of gases in other substances, most often of gases in liquids. Right? So and there's this Henry's law that basically says that the amount of gas dissolved in a solution is directly proportional to the pressure of the gas above the solution. And that's because if you increase the pressure, you're going to, like looking at this first picture, when we increase the pressure, as we keep putting on more and more pressure, those molecules are getting closer and closer together. They're more and more dense. The gas molecules are, so they're going to stay in solution better. All right, so increased pressure, you increase gas solubility. An example of this, real-world example, most of you probably see this every single day, and that is a soda can or any sort of soda. Soda bottles, soda cans, they're sealed under pressure to keep the carbon dioxide dissolved in the water and in the rest of the soda solution. Right? When you open the can or the bottle, you hear the fizz, and that gas starts to come out of solution. Because now that there's less pressure on the solution above it, those gas molecules can start to come out of solution. They start to spread out. They become less and less dense, and they won't stay in solution. Okay? And then temperature. Temperature is the other factor that affects solubility. So we have two different graphs here. One is for solids and one is for gases. So in general, if you increase the temperature, you're going to increase the solid solubility. In general. There's a couple exceptions, like the sodium sulfate and the cerium 3 sulfate. I don't know if it's a coincidence that they're both sulfates. Not sure. Both of those are decreasing in solubility as you increase temperature. But in general, solids will increase solubility as you increase temperature. And that's because you're making those molecules move around more. You're giving them more kinetic energy. They're going to want to interact, and they're going to stay in solution better as you increase the temperature. I mean, if you think about it, I don't know how many of you guys drink sweet tea, but if you've ever made it from home or at home, you have to heat the sugar water first. You have to heat the tea and you have to get it really hot to dissolve all that sugar. And then you let it cool and it makes a super saturated solution. If you were trying to dissolve, try this at home. Take regular room temperature water or, ice cold tap water or something like that, and take water and heat it up on the stove or something like that, and dissolve the same amount of sugar in both, the stuff in the hot water is going to dissolve faster than the stuff in the cooler water. Gases, however, are the opposite. All right? If you increase the temperature of a solution that has a gas, you're going to decrease the gas solubility. And this is because as you increase the temperature, those gas molecules are going to spread out more, so they're less dense, so they're going to leave the solution. Kind of like the opposite when we talked about the pressure. Right? If you were to take a soda can, or if you were to take soda and you were to put it in a pot and put it on the burner and heat it, you'll actually see those bubbles really come out of the soda because the gas does not want to stay dissolved when it's warm. Even if soda that you think is flat that you've had sitting out for a while, it will still evolve some more gas. It's pretty neat. All right, so this is just kind of a reiteration about talking of the temperature effects for aqueous solutions. So although the solubility of most solids in water increases with temperature, the solubilities of some substances decrease with increasing temperature. You don't need to worry about which ones they are. You're never going to have to memorize the solubility of any sort of substance. Just be able to understand what it is. So they might give you, it's like predicting temperature dependence of solubility is very difficult. Yeah, it is. So they're not going to ask you to memorize any of that stuff. Instead, they would give you a graph, a chart like this and say, okay, what is the solubility of, sodium bromide at 40 degrees Celsius? And then you would go on the chart, okay, 40 degrees Celsius, sodium bromide's right here, and you would look up whatever that number is. And you would say it's the solubility is so many grams of sodium bromide per 100 grams of water, or whatever. And that just boils down to understanding how to read the graphs, right? And then typically the solubility of a gas in a solvent decreases when you increase temperature.